Welcome to Lesson 9.6, Identify Symmetry. So, a couple different concepts and terms to think about first, and then we'll get into our examples. So, the first thing when I think about symmetry, I think about something being reflected over a line that's through the object. So, looking down here at example C, it's kind of the first thing I think of when I think of a symmetrical shape. Basically, could it be folded on itself and still have congruent parts? So, could we take this top, fold it over the line, and it's congruent with the bottom? Yes. So, that's a real basic example of symmetry. Now, what we want to think about is a figure in a plane. So, any two-dimensional figure has line symmetry, because there's also something known as rotation symmetry. So we're beginning with what's known as line symmetry. And a figure in a plane has line symmetry if the figure can be mapped onto itself by a reflection in a line. This line of reflection is the line of symmetry. A figure can have more than one line of symmetry. So figures could have 0 lines of symmetry, and then they are not line symmetric, or figures that are line symmetric could have 1 or more lines of symmetry. So if we look at example 1, simply asked how many lines of symmetry does the hexagon have? So we have 3 different hexagons, A, B, and C. Hexagon A has 2 lines of symmetry. One that's vertical, where if we would fold over that line, it would map it onto itself, and one line that's horizontal, where if we'd fold over that line, the top and bottom would map onto each other. This hexagon, which is a regular hexagon, meaning all the sides are congruent, has 6 different lines of symmetry. One that passes through the midpoint of opposite sides, and one that goes through opposite vertices, totaling 6 different lines of symmetry. And the C hexagon there, which we already looked at, has 1 horizontal line of symmetry. And then, moving down to example 2, asks how many lines of symmetry does the object appear to have? So it may not have exact perfect line symmetry, but how many does it appear to have if we're not going to take the time to measure all the angles, sides, and so on? So this first one with this floral piece, or flower itself it looks to be, has 8 different lines of symmetry. The starfish appears to have 5 lines of symmetry, and the visual of the mountain goat has 1 vertical line of symmetry. Then for part 4 of that example, it says draw a hexagon with no lines of symmetry. So in this case, all my sides happen to be different lengths, and none of my angles match up. So I know it would have no lines of symmetry. Many different options of ways you could draw a figure that's a hexagon with no lines of symmetry. So those are all examples of what's known as, again, line symmetry. Then we also have what's known as rotational symmetry. And what you want to think about with rotational symmetry is I always think about that little game you see toddlers play with the square peg, the round peg, the triangular peg. And if you can think about spinning that triangle or square, how many different ways can it fit through that opening? And if there's more than one way it fits, it's rotation symmetric. So rotational symmetry, you want to think about spinning an object around its center point, and if it turns into a congruent figure that matches up perfectly, it would be rotation symmetric. So a figure in a plane has rotational symmetry if the figure can be mapped onto itself by a rotation of 180 degrees or less about the center of the figure. This point is the center of symmetry. Note that the rotation can be either clockwise or counterclockwise, so rotation could go in either direction. For example, figure below, so kind of looking at this propeller blade here, figure below has rotational symmetry because a rotation of either 90 degrees or 180 degrees maps the figure onto itself. Even though 45 does not, that doesn't matter. If there's any scenario where a rotation of 180 degrees or less maps it onto itself, it has rotation symmetry. So if that's our original 45-degree rotation, not the exact same, but a 90 is the exact same as the original, same with a 180. So example 3, does the figure have rotational symmetry? If so, describe any rotations that map the figure onto itself. So this parallelogram, we know top and bottom are congruent to each other, left and right are, but not all four are the same, otherwise it'd be a rhombus. So this parallelogram does have rotational symmetry. If we'd spin it 180 degrees, it would give us the exact same figure. The regular octagon has rotational symmetry of 90 degrees or 180. If we'd rotate this 90 or 180, it would be identical. The trapezoid is not rotation symmetric because the only way that this trapezoid being rotated maps onto itself would be 360 degrees. Then example 4, looking at similar concept. Do the figures have rotational symmetry? If so, describe the rotations that would map the figure onto itself. So in this case, we have a rhombus. And yes, the rhombus, just like the parallelogram, has 180-degree rotational symmetry. This concave octagon has rotational symmetry of both 90 degrees and 180 degrees. And the right triangle here does not have rotational symmetry. And then we get down to example 5 here. Identify the line symmetry and rotational symmetry of the equilateral triangle at the right. So we're looking at this equilateral triangle. Identify the line symmetry and rotational symmetry. So if we think about an equilateral triangle, we'd have 3 lines of symmetry. From each vertex to the midpoint opposite sides, 1, 2, 3 lines of symmetry. So to figure out the rotational symmetry, if it has 3 lines of symmetry, I know that knocks me down to option A or B here. So then we want to think about the 60 or 120 degrees. Well, if I think about this triangle, there's 3 different ways I could spin it for it to look the exact same. So a full circle, full rotation is 360 degrees, divided by the 3 different ways we could rotate it to make it look the same within those 360 degrees, meaning it has rotational symmetry of 120 degrees. So our answer to this would be B, 3 lines of symmetry, 120-degree rotational symmetry. So remember, as you go through this lesson, we have 2 types of symmetry, one being rotational symmetry and the other being line symmetry.